Hey everybody, Mr. Stewart here at Math We've Got This, and welcome back. We are going to look at how we can use the exponent laws introduced in the first couple of videos in this series to simplify expressions. Okay, so when we hear about, let's grab the highlighter here. When we hear the terms simplifying algebraic expressions, we are looking to use operations, and in this case with the exponent laws. So the goal is to actually take what we have here, that is this expression, and we want to write it as the power with a single base. So that's our goal, okay? So notice that we are multiplying. Let's grab that highlighter again. So we have two powers, each with a base of y, and we're also multiplying those powers together. So thinking back to what you had experienced before, we would take those two powers, and let's grab that pen tool, that works a whole lot better, and we'll end up adding the exponents, okay, because we are using the multiplication rule. I'm just going to put that off and to the side in parentheses here. This is sort of our justification. So multiplication rule or law for operating on powers with the same base, okay? So that's important that you can articulate that. Let's not just write it, but let's make sure that we can say it and express it that way as well. So then altogether, final answer, y to the power of 8. And again, the goal in terms of simplifying is to write as a single power. Now, although it doesn't say that in the instructions, that's what it's going to mean when you're operating on powers with the same base. Okay, awesome. All right, next one. Let's have a look at what's over here on the right-hand side. So in this case, let's do a little highlighting here. We have, not only do we have powers that have the same base, and the highlighter works really well, powers with the same base, we also take note of the following. They each have a multiplier. So there's so many copies. Grab a different color here because it's not standing out. Here we go. They each have their own multiplier. So several copies of each of those terms, p to the 7th and p to the power of 3. And we're also dividing. So at some point, we're going to have to use that division rule when working with powers of the same base. So let's get this started. What I would recommend is, it's more of a personal a preference for me, really, is to take this form and write it as a fraction. Okay, to me, that demonstrates exactly what we're going to have to do. Just a better way of organizing our work as well. And I'll show you in just a moment why that's the case. So I also want you to realize, I mentioned that 6 and 3 are multipliers. And if that's the case, and it is, then we could rewrite that just by breaking them up. Really, it's no different. We're still multiplying. But I'm doing this with purpose. Okay, so everything we do does and should have a mathematical purpose. It makes sense. And that's what we're going to try to do, is to make sense of this. So notice that, I don't know if you recall, like in the last video where I was looking for like factors and I was trying to reduce terms, that is to 1 over 1. So I also want you to recognize that 6, right, is also made up of the factors 3 and 2. So that could be 3 multiplied by 2 and multiplied by p to the power of 7. And that's divided by, of course, here we have in the denominator, 3 times p to the 4. I'm just going to space that out a little bit. And again, I'm doing this with a reason. So recognize, just like in the last video, that we have like factors between the numerator and the denominator. Well, we know that those are going to reduce to 1 over 1. And I'm getting prompted that we have a matter of seconds left in our video. So let's see if we can wrap this up. That's going to reduce to 1 over 1. So we're left with 2 copies of p to the 7th, and that's divided by p to the 4th. And it looks like, unfortunately, we're going to have to wrap this up in the next video.